Section 0, Introduction. Welcome to the R3S Modeler Advanced Training Module. Projected Data Layers. In this course, we will introduce the Projected Data Layer functionality. This advanced module is designed to show you how to read in cash flows via the Projected Data Layer. The Projected Data functionality was introduced to allow models to read time and optionally scenario-dependent data to be passed directly into the corresponding time step in a projection layer. Some examples of how projected data can be used are reading asset or liability cash flows produced by a third-party application rather than having to model them in R3S Modeler. This gives the advantage of keeping the models in Modeler simpler. A projected data layer is a sub-layer of a projection layer and cannot be a sub-layer of the data layer or another projected data layer. A projected data layer contains a reference to a projected data process component. The projected data process consists of projected data sources, and each projected data source defines a mapping to the projected data. As a projected data layer is a sublayer of a projection layer, values from it can only be accessed if there is a corresponding record processed in the projection layer. To read projected data, it is necessary to have a data record processed by the data layer that can be passed into the projection layer. This data record can, in many circumstances, consist of just the record identifier, as the cash flows are read in from the projected data layer, and no further record-based calculations are necessary. R3S Modeler also has the capability of reading in more than one scenario of cash flows. In this case, a scenario variable is required to be defined in the projected data source. It is not possible to see variables from a projected data layer in the analyzer because of the potentially complex one-to-many relationship between a record in a projection layer and the many corresponding records that may exist in the projected data layer. In this module, there are 5 sections. Section 1. Read in aggregate record cash flows directly from an Excel file. Section 2. Read in aggregate record cash flows directly from an R3S run. Section 3. Read in multiple scenario aggregate record cash flows from an Excel file. Section 4. Read in grouped results directly from an R3S run. Section 5. Read in data from an Excel file into a parent program via a PDL and allow toggling of this functionality to be turned on or off. The videos are structured so you can follow along step by step at your own pace. Section 1.0. In this section, we will show you how to read external cash flows into a model from an Excel file. For this exercise, the same term cash flows that were initially calculated in the company model in the Life Foundation course will be used. This is to show there are no changes in results when feeding the cash flows in. In the company model, it will calculate cash flows for each term policy in the term program. In this section, we will now treat these cash flows as if they were calculated externally and being brought into our company model. To do this, we will have a new model structure with a projected data layer, which will read in aggregated record cash flows from an Excel file. Under this structure, in the term program, it will reference the value from the projected data layer. In this case, it is named External NP. For this section, the workspace we will be working on is Stage 1, Projected Data Start Point. It is saved in the Stage Workspaces folder, and we will be using the TA cash flows file. This is the screenshot of TA cash flows. These are aggregated results across all term policies, and these term cash flows are the same cash flows we calculated in the Life Foundation course. Section 1.1. To begin, open the Stage 1 workspace. Go to File, click Open. Under the Stage Workspaces folder, click on Stage 1 Projected Data Start Point and click Open. To read the data from the Excel file, we need to first set up the database view for a projected data layer. Go to the Workspace Explorer. Expand the Database Views folder. You will see there is a preloaded database view for TA cash flows. Open this database view. Go to the Variables tab. These are variables we need for the model, and they are highlighted in red as the value in the formula are not defined. You will notice the variables in this component match up to the columns of the TA cash flows files we want to read in. There are two ways to complete the database view. One is to use the database connection string and link the corresponding column to the corresponding variable. The other way is to paste the column name to the corresponding variable. To set up a database connection string, go to the General tab. Right-click in the Database Connection String window. Click Locate Database Connection String. Select OLEDB Provider for ODBC drivers and click Next. Click on Use Connection String and Build. Go to the Machine Data Source tab and click on Excel Files and press OK. Find the Excel file that we want to read in. In this case, it is TA cash flows. Before we close the window, we need to check the connection. Click on Test Connection. Make sure that the connection is successful. Then press OK and OK again. And we also need to specify the database table name. Right-click and select Locate Table and choose TA Cash Flows. Now we will set up these variables in the database view. Go to the Variables tab. For the first variable, CF Benefit Death, this will be read from the file. Let's delete the comments for all variables in the Formula property. Highlight the Formula property for all the variables and delete. For variable CF Benefit Death, click the Column property. Go to the Formula window. Right-click. Select the Locate Column option. You can see the list of column names in the Excel file. Select CF Benefit Death. Next is CF Com Renewal. Click the column property and go to the Formula window and right-click. Select Locate Column and select CF Com Renewal. Alternatively, you can just highlight the variable names, copy the variable names and paste to the column property. You will need to make sure the variable name is the same as the column name in the Excel file. For the variable PVFP step, the column name for this is PVFP. The reason behind having a different name for this will be explained when amending the code. Next, we will add a variable named policy_number. And assign the formula term results. Do not forget to include the quotation marks. As mentioned previously, we need to give the term cash flows a record identifier. The policy number will be the record identifier. Once the database view is completed, we can assign this database view to a projected data process. Next, add a projected data process. To do this, go to the Workspace Explorer. Find the Projected Data Processes folder. Right-click and select Add Projected Data Process. Call it term_projected_process. In the properties, set the start date as portfolio date and click Save. Each projected data source defines both the external file that holds the projected data and the specific data or database view used to process those records. Next, add a new projected data source and call it term. Apply the following properties. For category, it is TA data flow. For input source, it is database view. And database view will be TA cash flows. This is the database view we just completed. For the database connection string, we will connect to the TA cash flows spreadsheet using Locate Database Connection String. Similar to how we completed the database view, in the formula window, right-click and select Locate OLEDB Connection String. Select ODBC drivers. Click Use Connection String. Go to the Machine Data Source tab, select Excel files. Press OK. Navigate to the Data folder and select TA Cash Flows. Click OK. Click on Test Connection to confirm the connection. Click OK and OK again. For the database table name, in the formula window, right-click and select Locate Table. Select TA Cash Flows. Next is the property, Record Identifier. This will be policy number. The step date variable will be set to projection date. The projection data process is now complete. Now save your workspace. As mentioned earlier, a record identifier needs to exist on the data layer, which matches that in the projected data layer. So we will create a data view with this purpose. Go to the Workspace Explorer and find the Data Views folder. Right-click and select Add a new data view and call it external_term_data. Go to the Variables tab. Add the variable policy number. And set the formula to term results. Click Save. The data view is now complete, and this will be assigned to the new data process. We will add a new data process specific for the projected data layer record matching. Note that we could have added the term data source within the original company data process, but this would have affected the original company model. So for this purpose, a new data process was created. Go to the Workspace Explorer and find the Data Process folder. Right-click and add a new data process. Call it company_proj_term. Add a data source and call it term. And apply the following properties. For category, it is TA data flow. For input source, it is data view. For data view, it is external term data. And lastly, for the record identifier, it is policy number. Click Save. We have now completed the setup for the data process. Section 1.2. Next, we will cover the projection process. We will need to update the term code so that it retrieves cash flows from the projected data layer instead of calculating them internally. This workspace contains a partially completed module, Term Assurance PDL. Open this component from the Modules folder. Go to the Step tab. If we sort by formula, you will see there are two types of formula. Some cash flow variables have the same formula from the original term product module. These variables are summing up the cash flows we are reading in. For other variables, they will pick up the cash flows from the projected data layer. But we need to complete the formula for those variables. You may notice that the new term module includes most of the variables in the term product, but some are now redundant. Also, events are no longer necessary here, as the calculation of the term product is done outside of this model. In this module, we will read values from the projected data layer. First, delete the formula comment. To read the value from the projected data layer, we either use the layer name as a prefix. In this case, our projected data layer is named External NP. So for CF benefit death, the formula is external_NP.thisVar. And since it is a non-portfolio variable, we need to set the date range. And it is open bracket step_date.start to step_date.end, close bracket. Similarly, for other CF-related variables, we can simply copy the formula from CF benefit death and paste. For prob death, it will reference the variable number of deaths. So the formula is external underscore np dot number underscore of underscore deaths, open bracket, step underscore date dot start to step underscore date dot end, close bracket. Next is prob if. The formula is external underscore np dot number underscore of underscore policies. Since it is a portfolio variable, there is no need to set the date range. For other portfolio variables, the formula is simply external underscore np dot this var. So we can simply copy and paste the formula to the remaining variables. Now we have completed the step variables. Next is PVFP step. This variable will be referenced on the rollback tab via the PVFP variable. On the rollback tab, the variable PVFP will have the formula PVFP underscore step dot start. This is because it is not currently possible to reference sublayers directly on the rollback tab. As a result, the PVFP cache flows must first be retrieved via the step tab and then passed through to the rollback tab. We have now completed the module. Click Save. Next, we will copy the realistic projection process and assign the completed module to the new projection process. Expand the projection process. Click the realistic projection. Go to the ribbon and click under the Component tab. Select Duplicate and name it realistic underscore projection underscore proj. And click OK. Open the new projection process. Double-click on the term Program. Delete the submodules PVFP and Term Assurance. And delete the Reserve PP standalone variable in the Step tab. Go back to the General tab. Drag in the module Term Assurance PDL and click Save. Now we have completed the setup for our projection process. Section 1.3. We will now set up a new model for reading our external cache flows via the projected data layer. To do this, we can make a copy of the company model and amend some components. Go to the Models folder and click on the company model. Go to the Component tab and select Duplicate and name this company underscore proj. Open the model company proj. Open the data layer and add the data process company proj term and click Save. Since we have the company proj term data process, we need to suppress the term data source from the company data process. Open the company data process and suppress the TA data source. Set it to yes. Go back to the model. Similarly, open the reserving layer and suppress the term program, as we are no longer calculating the reserve for the term product. Go back to the model. Click the drop-down icon on the realistic layer. Change the projection process to Realistic Projection Proj, with the new module referencing the value from the projected data layer. Next, we will add the projected data layer. Right-click on the realistic layer, click Add Layer, and select Projected Data Layer, and select Term Projected Process. Name the projected data layer to external_NP. In the properties of the projected data layer, set the projection step lengths to 1 month. The company Proj model is now complete. Click Save. Now we can run the model in live mode. Call this run company_Proj. And click OK. We now have results for the company Proj model, but it would be useful to show the results from the company model to see that these results match. Open the company model and run it in live mode. Call the run company. Now both model runs are completed. To view and compare results, open the Results Comparison spreadsheet in the Stage Workspaces folder. Go to the tab Company Proj. It has been set up to display the results for Company Proj and to show the company results. Since we are using identical term cash flows, the non-profit fund program should produce the same results across both models. Let's update the workspace path, model name, and layer path for both models. Click on cell D7. Go to the R3S ribbon, click Insert, and click Workspace Path. Find the Result Workspace folder and click on companyproj.wvr and click Open. Next is the model name. Click on cell D8. On the R3S ribbon, click Insert and select Model Name. For the workspace path, click on cell D7 and then the model name, Company Proj, and click OK. For the layer path, click on cell D9. On the R3S ribbon, click Insert and select Layer Path. Fill in the following settings and click OK. For the company run, we will repeat the steps. Now both model results are updated. You can see there are no differences between the two models. This is the end of section 1. Section 2.0. In this section, we will show you how to read external cash flows into a model from an R3S Modeler Results workspace. For this exercise, the term cash flows from the company model in the Life Foundation course will be used. This is to show there are no changes in results when feeding the cash flows in. For this section, we will be working in the Stage 2 Projected Data Excel Endpoint workspace. It is saved in the Stage Workspaces folder, and we will be using the result workspace from the original company model. Section 2.1. We will start by opening the Stage 2 workspace. Go to File and click Open. In the Stage Workspaces folder, click on the Stage 2 workspace and click Open. To read a R3S Result workspace file to our model, we first need to run the company model. Go to the Models folder, click on the company model and run in live mode. While the model is running, we will create a new database view and a projected data process to read in the R3S Result workspace file. To do this, we can take a copy of the TA Cash Flows database view. Go to the Workspace Explorer. Expand the Database Views folder. Click on TA Cash Flows. Under the Component tab, click Duplicate. Name as TA_cashflows_WVR and click OK. Open this database view. Previously, this database view was used to read the results from an Excel file. To read results directly from an R3S Result workspace, we need to amend the projection date variable. This will be directly referenced from the system variable. To do this, we can simply change the column for projection date to be step date. And there is no underscore when defining this. Or we can make use of the database connection string and the database table to link with the results workspace to assist with the variable setup. Click Save. Next, take a copy of the projected data process, term projected process. Go to the Workspace Explorer. Expand the Projected Data Processes folder. Click on Term Projected Process. Under Component, select Duplicate. Name this Term Projected Process WVR. And click OK. Open this component. We are going to change the database view used from TA Cash Flows to TA Cash Flows WVR. As the source has been changed, we need to update the database connection string. Click on Database Connection String. Go to the Formula window, right-click and select Locate OLEDB Connection String. Click on Build and go to the Machine Data Source tab. This time, we are going to reference the R3S results. Click on R3S results and press OK. Click on Browse. Find the Stage 2 Projected Data Excel Endpoint folder. Click on Results folder, and you'll see there's a R3S Result workspace. Click on the Company Result workspace and click Open. Select Company Model and click OK. Click Test Connection and make sure the connection is successful. Then click OK. The database table name property needs to be updated as well. Go to the Formula window, right-click, select Locate Table, and choose A term. A represents the aggregated output report, and A term is the aggregated results for the term program. Click OK and save. We have completed the projected data process. Section 2.2. We will now create a new model for the projected data layer to link the R3S Result workspace. To do this, we will make a copy of the Company Proj model. Click on the model Company Proj. Under the Component tab, select Duplicate and name this Company_Proj_WVR and click OK. Open the Company Proj WVR model. In the Projected Data Layer External NP, click on the drop-down box. Replace Term Projected Process with Term Projected Process WVR. And click Save. Now the projected data layer is linked with the R3S results, with everything else being the same as in Section 1. There are no changes made to other components. This section shows how our model can use another set of R3S model results by passing the run results into the model via the projected data layer. Now let's run the model in live mode. Name this Company_Proj_WVR and press OK. To view the result, let's open the result comparison spreadsheet. And go to the Company Proj WVR tab. Again, we are comparing the result between Company Proj WVR, where it's referencing the results from the company model. Let's update the workspace path, model name, and layer path for both models. Click on cell D7. Go to the R3S ribbon. Click Insert Workspace Path and make sure you are in the Stage 2 Projected Data Excel Endpoint Results folder. Click on Company Proj WVR and click Open. Next is the model name. Go to the R3S ribbon and select Model Name and enter the following. For the layer path, enter the following. Next is the company model. Enter the following in column P. Once you have updated both sets of results inputs, you should see that there is no difference between the results of both models. This is the end of section 2. Section 3.0. In this section, we will show you how to read in cash flows from an Excel file for multiple scenarios. This involves creating a stochastic process to read in the multiple scenario cash flows, and it will produce a set of results in the realistic layer. In this section, we will also show how to use the stochastic return value variables property to do post calculations on the scenarios being read in before being passed to the main layer. To do this in the same model, we need to change the stochastic realistic layer to be a sublayer and pass the mean output from the sublayer to the top layer. But by doing this, there is the drawback where previously you could distribute scenarios to workers when the top layer was stochastic. This can no longer be done, as the stochastic process is on a sublayer. An alternative way to do this would be to do the scenario runs and mean calculations in a separate model, and then feed those cash flows into the main model, thus allowing those calculations, which are not stochastic, to continue to run deterministically. In this example, we will add a sublayer. For this section, we will be working in the Stage 3 Projected Data WVR Endpoint workspace, and we will be using the TA Cash Flows 10 Scenario Excel file. Section 3.1. To begin, let's open the Stage 3 workspace. Go to File, click Open. Under the Stage Workspaces folder, click on Stage 3, Projected Data, WVR Endpoint, and click Open. We will create a new database view and projected data process to read in the scenario-dependent cash flows. Go to the Workspace Explorer. Expand the Database Views folder. We're going to make a copy of the TA Cash Flows database view. Click on TA Cash Flows. Under the Component tab, click Duplicate and name it as TA_cashflows_sen and click OK. Open this component. Go to the Variables tab. Add a new database view variable named scenario_number. Set the data type property to indicator. Set the portfolio property to yes. For the column property, enter scenario number. which matches the column name in the Excel file. Save the database view. This completes the setup for the database view used in the projected data process. Next, go to the Workspace Explorer and expand the Projected Data Processes folder. We're going to make a copy of Term Projected Process. Click on Term Projected Process. Under the Component tab, select Duplicate and name it term_projected_process_sen. Click OK and open this component. Update the database view to use TA cash flows sen. Since we are referencing a different file, we need to update the database connection string. Click on the database connection string property. In the formula window, right-click and select Locate OLE DB connection string. Click Build. Go to the Machine Data Source tab, select Excel Files, press OK, and navigate to the Data folder. Find the file TA cash flows 10 sen. Click OK, then click Test Connection and confirm it's successful. Press OK twice. Now we will introduce a placeholder variable to make the data links dynamic. Instead of hard-coding the file path, we will parameterize the results path so it can be changed at runtime. Highlight the workspace path and replace it with the system placeholder variable workspace folder. Next, we need to set the scenario variable property. Click on the scenario variable property and enter scenario number. Click Save. We've now completed the projected data process for use in the new model. Go to the Models folder in the Workspace Explorer. We're going to take a copy of the model, Company Proj. Click on Company Proj. Go to the Component tab, select Duplicate. Name it model_company_proj_sen and press OK. Open this model. Change the projected data process in the projected data layer to Term Projected Process sen. Click Save. Section 3.2. We will now create a stochastic process for the realistic layer. To do this, we first need to set up a data view for the stochastic process. Go to the Workspace Explorer. Click on Data Views. Right-click and select Add Data View and name it Scenario_Data_View. This data view will generate the values for the variable scenario number, so that the values in the stochastic process can match up with the same variable coming from the projected data layer. In this case, we are not using an input data file. Instead, we'll use the range function to generate those records. Go to the Variables tab. Add a variable called scenario number. In the formula property, enter range open bracket 1, 10, 1 close bracket. Click Save. This gives 10 scenario numbers and completes the data view for the stochastic process. Next, create a new stochastic process. Right-click on Stochastic Processes and click Add Stochastic Process. Name it Stochastic. Set the input source to Data View. Set the data view to Scenario Data View. And set the scenario variable to scenario number. And click Save. This stochastic process will be used in the model Company Proj Sen. Open the model Company Proj Sen. Click the drop-down arrow for the realistic layer and add the stochastic process to this layer. Click Save. Next, we will use a filter component to filter the first 5 scenarios. Go to the Filters folder in the Workspace Explorer. Right-click, select Add Filter, and name it First_5_scenarios. Set the filter formula to Scenario number is less than or equal to 5. Click Save. Now assign this filter to the stochastic process. Open the model Company Proj Sen. Double-click on the realistic layer. Go to the Stochastic Processes tab and assign the filter to the filter formula. Note, the filter name should end with a question mark when used in this field. Click Save. We can now run the model in live mode. Click on the Company Proj Sen model. Click Run. Name this Company Proj Sen. And press OK. The model will now run 5 scenarios. Because the number of scenarios is small, they are processed very quickly, so you may not see the scenario cycle appearing in the progress log. Let's open the spreadsheet Results Comparison. Go to the folder and open the Results Comparison Excel file. Go to the tab Company Proj Sen. Columns B to J show the results for Company Proj Sen. Columns O to V show the results for the company model. First, let's update the result workspace path for Company Proj Sen. Make sure you find the right result workspace. In this case, the result is Company Proj Sen. Press Open. The model name is Company Proj Sen. Press OK. Click the details of the layer path. The layer path window gives the option to select the scenario number. Select 1 and press OK. We are going to compare this with the results from the original company model. Click on cell P7. Go to the R3S tab, click Insert, and then Workspace Path. We can use the previous results from Stage 2. Go to the Stage 2 Workspace folder. Go to the Results folder and click on the Company Result workspace and open. Then insert the model name. Update the layer path. For the Company Proj Sen results, you will see that the layer path includes the scenario number. The one shown here indicates results from Scenario 1. When you scroll down, you will see that there is no difference, because the Scenario 1 result is the same as the company model. If we change it to Scenario 2, you will see there are differences. Similarly, for Scenario 3, there are differences, as expected. We have now shown how to read in different scenarios into R3S Modeler. Section 3.3. We are now going to show how we can use stochastic return value variables to return mean values within the same model. This is the model structure we are going to build. There is a top layer without a stochastic process that reads values from the sublayer. The sublayer has its own stochastic process and returns the mean output to the top layer. It also reads values from the projected data layer for different scenarios. The first thing we'll do is create the projection process for the new sublayer. Go to the Workspace Explorer, right-click on the Projection Processes folder, click Add Projection Process, and name this stochastic_projection. Go to the Properties and set the start date to portfolio date. In the central panel, we are going to add a term program. Right-click, select Add Program, name it Term, and go to the Properties. The category for the term program will be TA Dataflow. Click Save. Next, we need to assign the corresponding module to the term program. To do this, take a copy of the module Term Assurance PDL. Go to the Modules folder. Click on Term Assurance PDL. Go to the Component tab, click Duplicate, and name it term_assurance_PDL_sub_layer. Press OK and open it. Go to the Step tab. We're going to remove some variables that don't read in values from the external NP projected data layer. Sort the formulas to better identify these variables. Highlight the ones which have original formula in the formula, right-click and delete the variables. Click Yes to all. The reason we're deleting these variables is that those calculations will now be done in the calling layer, whereas the sublayer will only read values from the projected data layer and output the mean values to be passed back to the calling layer. Go back to the stochastic projection. Double-click on the term program, assign the new module by dragging it in, and then click Save. Now we are going to create the model structure for the new model. Make a copy of the company ProjSen model. Highlight it. Go to the Component tab, click Duplicate. Name it company_proj_sen_mean and press OK. Open it. First, delete the external NP projected data layer. Right-click on it. Select Delete Projected Data Layer and click Yes. Next, add a new sublayer to the realistic layer, which is a stochastic layer. Right-click on the realistic layer, click Add Layer, select Layer as the component type, and press OK. For the projection process, select Stochastic Projection and press OK. Name the new layer stochastic_layer. And press Enter. Go to the Properties panel. Set the projection step length to 1 month and make sure the start date is set to Portfolio Date. Now we'll add the external NP projected data layer into the new stochastic layer. Right-click on the stochastic layer, select Add Layer, click on Projected Data Layer, and press OK. Choose Term Projected Process Sen, and press OK. Name this projected data layer External NP. In the Properties panel, set the projection step length to 1 month. And confirm the start date is Portfolio Date. Click Save. This is the model setup for returning the mean value from the sublayer in the same model. Next, we will create a stochastic process that will return the cash flow mean values from the sublayer to the main layer. To do this, take a copy of the existing stochastic process. Click on Stochastic. Go to the Component tab, click Duplicate. Name it stochastic_mean and press OK. Open it. Go to the Variables tab. We are going to copy all the variables from the module Term Assurance PDL sublayer and paste them into the Stochastic Return Value Variables grid. Open the Term Assurance PDL sublayer module. Highlight all the variables. Copy. And go back to the stochastic mean stochastic process and paste in the variables. For the formula, use the mean function. For each variable, the formula is simply mean this var. copy and paste this formula as needed. Click Save. Now we are going to assign this stochastic process to the model. Open the Company Proj Sen Mean model. Click the drop-down box on the stochastic layer. Drag the stochastic mean process into the stochastic layer and click Save. This completes the setup for the stochastic sublayer. Section 3.4. Now we are going to set up the projection process for the top layer. To do this, make a copy of the projection process, Realistic Projection Proj. Go to the Workspace Explorer, expand the Projection Processes folder, click on Realistic Projection Proj, go to the Component tab, click Duplicate, name it realistic_projection_proj_mean, and press OK. Next, we'll take a copy of the module Term Assurance PDL. This module will be used in the term program for the new Realistic Projection Proj Mean projection process. Click on Term Assurance PDL. Go to the Component tab, click Duplicate, and name it term_assurance_PDL_calling_layer. Press OK and open it. Go to the Step tab. Instead of reading the value from the projected data layer, external NP, we will now reference the value from the sublayer, which is stochastic layer. The stochastic layer will return the stochastic mean output. To make this update efficient, we can use the Find and Replace tool. Open the Find and Replace tool. In the Find What box, type external_NP. The component we are working on is Term Assurance PDL calling layer, so select that component. Under Fields, click on All Fields, then click Find. You will see 15 matches found. These should be replaced with stochastic_layer. Highlight all matches and click Replace. You will see that the prefix has now been updated to stochastic layer. We'll do the same for the comments. Type Projected Data Layer in the Find box again. Find all matches and replace them with stochastic layer. You will now see that the module is picking up values from the stochastic layer. You can sort the formula column to make it easier to view. All the formulas now reference the stochastic layer. For two variables, probDeth and probIf, we need to manually adjust the formulas. Because we are now referencing the mean values returned from the stochastic mean process, the variables returned are named probDeth and probIf themselves, not know of deaths or know of policies. so the formula for both variables is simply this var. This completes the setup for the module that will be used in the term program of Realistic Projection Proj Mean. Now open the Realistic Projection Proj Mean projection process. Double-click the term program. We are going to delete the Term Assurance PDL module currently applied. Right-click on it, select Delete Module, and click Yes. Then drag in the Term Assurance PDL Calling Layer module and click Save. We now need to assign this projection process to the top layer of the model. Open the Company Proj Sen Mean model. Click the drop-down box for the Realistic layer and change the projection process to Realistic Projection Proj Mean. Next, delete the stochastic process assigned to the Realistic layer. Press Delete on your keyboard and confirm by clicking Yes. Save the model. This completes the setup for the top layer to read mean outputs from the sublayer. Once the model is saved, we're ready to run it. Click on Company Proj Sen Mean and run the model in live mode. Name the run Company Proj Sen Mean and press OK. We'll now view the results using the Results Comparison spreadsheet. Open the spreadsheet and go to the Company Proj Sen Mean tab. On the left-hand side, we have the model results from the Company Proj Sen Mean result workspace. On the right-hand side, we have results from the original company model. First, update the result workspace path, model name, and layer path for the original company model. Click on cell P7. Go to the R3S ribbon, click Insert, and choose Workspace Path. Use the previous result workspace from Stage 2. Select the Company Result workspace and click Open. Insert the model name and update the layer path. Now update the left-hand side with the result path for Company Proj Sen Mean. Use the result from the Stage 3 results folder. Select the Company Proj Sen Mean result workspace and click Open. Update the model name and layer path as well. Now you'll see the mean outputs from the Company Proj Sen Mean model. On the right-hand side, you'll see the values from the original company model. There are some differences between the models, but that's expected, because one shows the average output across multiple scenarios, while the other reflects just a single scenario. This is the end of Section 3.